Hello, welcome to the third installment video for the August 2016 Algebra 2 Common Core or Regents exam. Now, I think we're going to do problems, 17 through 24 today. Shouldn't take us that long, hopefully. I don't know, forecasting. But let's jump right in and start with the number 24. No, let's not go 24 backward. Let's go 17 forward. And there's 17. The focal length f of a camera's lens is related to the distance of the object from the lens J and the distance to the image area in the camera W by the following formula. Okay? 1 over J plus 1 over W equals 1 over F. When this equation is solved for J in terms of FW, J would equal, so basically they're just saying they want J equals something, okay? All this stuff we don't even need. That's nice to know. We need this, and we know we need to solve for J, okay? And that's exactly what we're going to do. So let's get started. I'm going to rewrite this. 1 over J plus 1 over W equals 1 over F. I need to get this J alone. So what I'm going to do, I could do this two different ways. Let me do it this way here. Okay, let me get a common denominator between all of these, so then I can just wipe the denominators right out. Okay, I see a J, a W, and an F. All right, I see a J, a W, and F in each of the denominators. So wouldn't it be great if there was a J, W, F in all of the denominators? And that's what we're going to do. Okay, so this is a J. It needs a W and an F. So I'm going to multiply this by WF. What I do to the bottom, I need to do to the top to keep it the same. All right? Now, the middle fraction has a W. It needs a J and an F. So I'm going to multiply this by JF. What I do to the bottom, I need to do to the top. All right? And last but not least, this one on the far right has an F, but it needs a J and a W. So I'll multiply that times JW. What I do to the bottom, I need to do to the top. So let me rewrite this whole thing fancy, okay? 1 times WF is just WF over. The bottom is JWF. Plus JF times 1 is just JF. All over the bottom is JWF. Okay, please remember, in multiplication, order doesn't matter. Okay, so I'm just writing the 3 letters in the bottom in the same order for all 3 fractions. Okay, equals 1 times JW over JWF. Now, if I have an equation with all fractions and the bottoms are all the same, cross them out. Okay? Let me rewrite what I have here. I have WF plus JF equals JW. Now, I need to solve for J, right? I need to get J alone. So I'm going to subtract JF from both sides here. So when I'm all done, this goes bye-bye. So I've got WF equals JW minus JF. I'm going to factor out a J. Okay, if I factor out a J, I now have W minus F. I factored a J out from both. Equals WF. The last step I need to get J alone is I'm going to divide by W minus F. Divide by W minus F. So ultimately, J equals, okay, I'll write these in what they tend to do is write these alphabetically. So the F comes before W, all over W minus F. Okay? And oh, goodness gracious, this. Now look it is not choice 2 because in subtraction, order matters. I can't just switch that. In addition and multiplication, order does not matter. F plus W is the same thing as W plus F. Same thing with multiplication. Okay? But keep in mind that W minus F is not the same thing as F minus W. Okay, subtraction and division order matters. So my bottom needs to be the W minus F. All right. Now, I mean, there were other ways to do this. This is just the way I did it. It seems to be easy for me because I like this part right here, where I can just wipe out the bottom. Okay, 3. Number 18, the sequence where A equals A1, I'm sorry, the first element is 6, and every element after that, A to the N, you take 3 and multiply it times your previous element. Okay, that's what that means, A to the N minus 1. Can also be written as what? So what I like to do is I'm going to just write this out. If my first element is 6, okay, my next thing says I take 3 and multiply it times my previous one. So if this is A1, how do I find A2? I take 3 and multiply it times A1, okay? Times 3. That will give me 18, right? Okay, now if I want to find the third element, I take 3 and multiply it times A2. Okay, so I multiply this times 3 again, and I get 54, and so forth. So one of these choices, all right, 1, 2, 3, or 4, should give me the same sequence, all right? Should give me the same sequence. So let's figure out which one it would be. Let's try number 1. Okay, now keep in mind this N is this right here. 1, 2, 3. It's the element, like the position it's in. So let's try a 1. If I put a 1 in for N, will I get a 6? Okay, if I put a 1 here and I put a 1 here, 6 times 3 is 18. That's not 6, so it can't be that one. All right, let's try putting a 1 in for this one and see if I get a 6 for the first element. 6, well, 3 raised to the power of 1 plus 1, that's 2. So that's like 6 times 3 squared. That's 6 times 9. That's 54. That's definitely not the first element. Okay, let's take a look at 3. If I put a 1 here and a 1 here, I get 3. 2 times 3, well, that's 6. Okay, the first one works. Let's see what happens if I put a 2 there. Let's see if I get 18. Okay, let's cross this out. Let's put a 2 here and a 2 here. That's 2 times 3 squared is 9. 2 times 9 is 18. Oh, hey, look at this. Let's try putting a 3 there for my N's. If I put a 3 here, I got to put a 3 here. That's 2 times 3 cubed. 3 cubed is 27. If I multiply 27 times 2, I get 54. Look at that. Bam, that matches exactly. Now, if you want, you can check 4. Let's check 4. Let's start with 1. Let's see if we put a 1 in, if it outputs a 6. If I put a 1 here and a 1 here, I get 2 times 3. Well, 1 plus 1 is 2. That's 2 times 9. That's 18. That first element is not 6 either. So choice 3, that's just simple algebra. Just work it out. To me, that makes the most common sense in how to do it. The answer is choice 3. Right, 19. I like this problem, but it really mentions something that, I mean, in class you barely touch on. But once you get past that, there should still be something that you should know. Which equation represents the set of points equidistant from line L? Okay. Oh, let's use highlighters. Boom. Line L is this line right here. And point R, which is right here. Okay. Now, in case you didn't know, if you have a set of points that are the same distance from a line and a point, okay, that's a parabola. See, that's exactly in between. This will be exactly in between here. This will be exactly. It would start to wrap around, and that's a parabola. So really what they give you, your line and point, is your directrix and your focus. Yeah, I should spell focus correct. That would help. Okay? If you know that, you are going to just knock this problem out of the park. Yeah, that's a home run. Anyways, let's take a look at this. I know that if this is my directrix, L, and this is my focus, that my vertex is exactly in between. So we have 1, 2, 3, 4. That's a distance of 4, okay? So if I go halfway, if I go 2 up, and if I go 2 down, that's where my vertex should be. This point right here is my vertex. Okay, which means my parabola does something like this, opens down. My parabola never crosses the directrix line. No, it always kind of wraps around your focus point, all right? So if I look at this vertex, I know it should open downward, which means it should be negative. All these are negative, okay? So I can't cancel any of the 4 options. Here's what's going to help you solve this problem. What is the coordinate of the vertex? That coordinate, okay, if I do this right, let's do this in yellow. 1, 2 on the x, so it's 2, and I move down 1 to -1 on the y-axis, all right? You'll notice that all these problems, 1, 2, 3, and 4, and I can't remember if it was a June 2016 or if it was an earlier problem in this August 2016 exam. This is the vertex form of a parabola. We are so used to seeing ax squared plus bx plus c. We're used to seeing something like x squared plus 8x minus 4 for a parabola. This is a standard form. These all listed here are vertex form. Why are they called vertex? Because the vertex is given in each problem. This number and this number help you identify the vertex. See that? This number and this number. This number, this number, this number, this number. All right? So what we need to do is identify, well, okay, how can I tell the vertex from the vertex form? The vertex form of a parabola is as follows. Y equals it's some number a times x minus h squared plus k. H and k are the coordinates of your vertex. Keep in mind, this h is negated. Okay, this k is not. So whatever the k is, you keep as k. So my k will stay the same, -1. Okay, there's a -1 here, and there's a -1 here. So it can't be 3 or 1. My h value, I got to flip the sign. Okay, every time I am in parentheses, for some reason in mathematics, anytime I need to pull a number out of a set of parentheses, I need to flip the sign. I need to negate it. So I have a 2 here, but if it was in the parentheses, it would have to be a -2. Because a -2, when I pull it out of the parentheses, would become a +2, okay? So if I look here, this is +2. If I take this out of the parentheses, that would become a -2. I don't want a -2. I want a +2, okay? This one right here is -2. If I pull that out of the parentheses, that becomes a +2. This number stays the same. That's a -1. That's my vertex right there. That's my vertex right here. And number 4 is your answer. All right? Let me just, if that seems a little bit confusing right now, I'm going to give it to you very, very simple right now. Okay? And my students hate when I do this and over-explain things, but sometimes people need to hear things a different way. Let's look at number 4, our option. Okay, y equals -1/8 times x minus 2 squared minus 1. In order to get my vertex, my x and my y, this stays the same. This has to flip signs. It's not -2, it's +2. That's it. And you look at each one of those 4 responses and you do that same thing. And you figure out, well, which one's going to give me my vertex of 2, -1? And it's choice 4. Number 20. Mr. Farathan gave his class the 3 mathematical rules shown below to either prove or disprove. Which rules can be proved for all real numbers? So which 2 of these are true and which, oh, dang it, I know what the answer is. And 2 of them happen to be true. But which of these are true and which of these are false, okay? I'm going to take a look at this first one now. I know I told you that if you graph something in y1 and on the other side in y2, if the graphs are the same, that means they're equal. But that's only if there's one variable. You see, for 1, you have an m and a p. two variables. I can't do that. For 2, we have an x and a y. Can't do it in a graphing calculator. And for 3, we have an a and a b. So the graphing calculator is useless to us at this point. So I know for a fact that number 1 is true. If I take m plus p and I square it, okay? Do not just square m and square p. You need to FOIL it. Okay. M squared. That's plus m times p. We have another m times p, and then we have a p squared. There should be a plus in between there. Ha ha. Don't know where that came from. We don't want that. Plus p squared. I can combine these. So I have m squared plus 2mp plus p squared. Good. Number 1 is true. Number 2, if I take x plus y and cube it, that means I need to take x plus y, multiply it by itself 3 times. And I know for a fact my first term should have x cubed, because it's x times x times x. My last term should have y cubed. But the terms in between them, I should have x squared y to the 1. Then I should have y. I should have x to the first, y squared plus. Okay, the exponents should always add up to 3. Meaning, now, the coefficients, I don't know what the coefficients could be. I mean, I know for a fact it's going to be 1, 3, 3, 1. You guys might not know that. There's something called Pascal's triangle that helps us to determine that. But let's take a look at the exponents here. Since this is 3, all my exponents should add to 3. You see this is x cubed? I should have 0 y's there. See, I have 2 x's and 1 y. That adds to 3. Then also notice 1 and 2. And then I have 3 y's and 0 x's. All right? So I should have 4 terms when I cube something. Do I have 4 terms here? No. So right now, my answer should have 1 in it. Okay, this is a 1, this is a 1, this is a 1. Okay, let's cross out 3. 3 is no good. So the $1 million question is the third Roman numeral 3, is that true? It doesn't look true, but you know, every once in a while the test tries to throw a curveball at us. Let's see if this is the case. I'm going to take a squared plus b squared, and I'm going to square it. So I'm going to take a squared plus b squared and multiply it times itself. All right? So that's a to the 4th. It's plus a squared b squared. That's plus another a squared b squared. That's plus b to the 4th. All right. That doesn't look like this right here. But you know what? The right side of that equation can also be worked out. Okay, it's not simplified. Like this side is simplified, this side is simplified. This is not. Let's simplify this right side, and let's see if we get the same thing we do here. Okay, so I'm going to have a squared minus b squared. That's got to be squared. And I'm going to add that to 2ab squared as well, so times itself. I've got to square that, okay? So let's do this together, and let's see if we get the same thing I do right here. Okay, if I FOIL this, I'm going to get a to the 4th minus a squared b squared, 8 minus a squared b squared, plus, because a negative times a negative, plus b to the 4th. All right? Plus, if I multiply these together, I get 4 a squared b squared. All right, so let's combine like terms. I have a to the 4th. Okay, let's look at my a squareds, b squareds. All right, I have 4a squared b squared minus 1a squared b squared minus another 1a squared. So 4 minus 1 is plus 2a squared b squared. And now I have this, plus b to the 4th. So does this equal this. Well, is there anything I can combine here? There is. These two in the middle combined. So I have my a to the fourth. I have 2 a squared b squared. And then I have my plus b to the fourth. Yeah, those are equal. Look at that. Man. That's a lot of algebra. So 1 is also, excuse me, 1 is true and so is 3. Choice 4. That was a lot of algebra. But 1 and 2 I could have done myself. And if you get good at foiling, I showed you all the work. If you get good at foiling, you can do it quicker without showing every single step. This third one, that's really the one that's going to take the work. All right? That's really the one. And you know what? You have 3 hours to do this test. When you get done with everything else, and you still have 45 minutes to an hour left, take the time, okay? Take the time and do it. Do it. 21. The graph of p of x is shown below. Oh, that's a nice little, looks like it's cubic. It's an, function with an odd degree. Anyways, what is the remainder when p of x, which is this graph right here, is divided by x plus 4? All right, if you know the remainder theorem, because they're asking what the remainder is, that makes this a piece of cake. By definition, the remainder theorem says, if I take something, okay, let's say I take, I'm going to pull away from this problem for a second here. Let's say I take x plus 3, and I want to know what the remainder is when I divide. Let's call it x squared plus 2x plus 5. Okay, I don't care about the quotient, just the remainder. I can take my x plus 3 and solve it, like Booty Cheek It and T-Bone. My answer would be x equals -3, right? That means I can take -3 and plug it in for all these x's. Let's say this was f of x equals this. And I'm going to divide it by x plus 3. I can take f of x and put a -3 in there, and whatever the answer is, that's my remainder. Okay, so let's do that. Okay, I take -3 and I square it. I add 2 times -3 plus 5. That's 9 minus 6 plus 5. That is 8. The remainder is 8. Okay, so f of -3 would equal 8. 8 is my remainder. Keep in mind, this is a coordinate. When x is -3, my y would be 8. Okay? That same idea, like when you plug in your x, your y is your remainder, correct? We're going to do right here with this. I'm going to solve that like it is a booty cheek. X plus 4 equals 0. That means x equals -4. Whatever I plug a -4 into this function, the y value is going to be my remainder. All right? So here we go. -4 is -1, -2, -3. Oh, -4 right there. The y value, that coordinate is -4 is 0. There you go. I mean, if I was doing this on the test and knew what I was doing, I don't have to explain this on the test. I explained it to you so you know what I'm talking about. If I would have just done this, you might have been like, Visca, I have no idea. And I would have been like, I know, I saw the look on your face. But let's draw a little tail here in the arrow. But there you go. So I explained it for you. Good job. 22. The payday loan company makes loans between $100 and $1,000 available to customers. Every 14 days, customers are charged 30% interest with compounding. In 2013, Remy took out a $300 payday loan. Which expression can be used to calculate the amount she would owe in dollars after 1 year if she did not make any payments? Okay, here we go. So first of all, she borrowed $300. That's the initial amount. They all start with 300. Okay, so I can't cross anything out. Customers are charged 30% interest. That means if I'm doing growth and decay, your initial amount times 1 plus or minus your rate in time, which is generally in years or whatever increment that is. All right, so let me ask you this. All right, she's obviously going to pay back more money than she borrowed, so the rate is going to be added. 1 plus 30%, in your parentheses should be 1.30, okay? 30, no. 30, I wish, bye-bye, okay? So no, it's choice 2 or 3. And here's what's going to throw you off, all right? Now, her interest gets applied every 14 days, all right? Every 14 days. Now, common sense tells me that 14 days is the same thing as 2 weeks, right? This is how I look at it. All right, 2 weeks. So if in a matter of 1 year, all right, after 1 year, how many 2-week increments are in a year? Well, there are 52 weeks in a year. And if I divide that by 2, that means there'll be 26 times this needs to get applied every 2 weeks. All right, if there are 52 weeks, and I see how many 2-week increments there are in 52, it's 26. Okay, so this interest rate has to be applied 26 times. Which exponent represents 26? This one. If you take 365 and divide it by 14, you get 26.0 something, whatever. Okay, 14 divided by 365 is not 26. Okay, boom. That's not the answer. It's this one. And if you don't trust me, I did this problem earlier. Okay, if I take my exponent, 365 divided by 14, there are my 26 times that interest gets charged. Choice number 4. I think this would have given problems to people just by the way it's worded and you know the 365 and the 14. I think it would throw people off, but it's not impossible. It is doable. Oh boy, here you go. Generally, these 3 equations with 3 variables are saved for short answer, but it says which value is not in the solution of the system. I can't just use a calculator and plug in values because -2 would go for where? A or B or C. Let's say it goes for C. Well, what would A and B be? You'd have to pick other numbers, and this would be kind of a hassle. You've got to do this algebraically. All right? Let's see. So I'm going to use the first 2 equations, and I'm going to get rid of my 5b's there. That works out nicely. So I've got A plus 5b minus c equals -20. And then I got 4a minus 5b plus 4c equals 19. I'm going to add these 2 equations together. A and 4a give me 5a. Cancel. Nice. Okay, 4c minus 1c is plus 3c. And if I add -20 and 19, I get -1. All right? So now I'm going to take 2 more equations. I'm going to take the first one and the last one. All right, I'm going to do the same thing, combine them, and I'm going to get rid of the b's. So I've got a plus 5b minus c equals -20. And I've got -a minus 5b minus 5c equals 2. Let's add these. Oh, glory, look what happens. Not only does my 5a and 5b cancel, my positive a and negative a cancel. -5c and -1c is -6c equals -20 and 2 is -18. I can solve for c right here. Look at that. Woo! If I divide both by -6, I know that c equals 3. Okay, 3 is an answer. They want to know which one is not an answer. Okay, 3 works. Let's throw 3 in for c here. 5a plus 3 times c, which is 3, equals -1. I'll be okay. I was going to make that a 9 because I was always thinking 3 times 3 is 9. So 5a plus 9 equals -1. All right. Well, I'll do it this way. I know what the answer is going to be, but let's subtract 9. 5a equals -10. So if I divide by 5, a equals -2. Sweetness. That's there. I would have an issue if I came up with A and C and they were not listed, but I'm feeling good. So now let's pick any one, the first, the middle, or the last, and plug in a C and A to find B. I'm going to pick the last one because the numbers seem smaller. So I have -a minus 5b minus 5c equals 2. Now keep in mind, you could have picked the first or second one. People might not want to pick the third one because, oh, there's all negative signs. It's fine. Wherever you plug in A and C in either equation, your B will come out to be the same. All right, so A is -2, so I negate a -2 for my A. Minus 5B minus 5 times C, which is 3, should equal 2. Yep, so we have a +2 when I negate a negative, minus 5B minus 15 equals 2. Let's combine some things. Let's add 15, add 15. Let's subtract 2, subtract 2. Bang, bang, we got -5B equals, my 2's cancel, 15. All right, I like what's happening here. If I divide by -5, B will equal a negative divided by a negative. Right? No, that's a positive. That's the equal sign. Woo-hoo-hoo. That is -3. That is a correct answer. 2 is the only number that is not in the solution set. Woo! Might need a break, but no, we're not taking one because we have one more problem to do to get to 20. Yep, that's that. We have one more problem to do to get to 24. Let's do it. 24. In 2010, the population of New York State was approximately 19,378,000, with an annual growth rate of 1.5%. Assuming the growth rate is maintained for a large number of years, meaning this won't change, okay, which equation can be used to predict the population of New York State T years after 2010? All right, so T years after 2010. Again, I would like to just use some numbers and just start calculating them and see what numbers come up and see which one of these gives you that same pattern. That, in my mind, is the easiest thing to do. It may or may not work for you, but that's what I think I'm going to go ahead and do. But I think before I do that, I'm going to kind of set this up. My growth rate is 1.5%. That means it's 0.015, okay? If I were to do growth decay equation, I would have my starting amount times 1 plus my rate raised to time. So I'd have 19,378,000 times 1.015 to the t. Okay? If I look at this, I look here, that's not the same. Okay? They just put 1.5 right here in the expression. That's wrong. My board is stroking out. Okay, so that's right. I know it can't be 1. And I look at 3. Okay, 3, that's good. Everything looks good here, but guess what happens at the exponent? It's not t, it's t minus 1. So that's not going to give me any help right here either. So basically what I need to do is I need to take 2 and 4 and check this out. All right, so let's do this here. Let's do this. Let's start trying these. Okay, after year 1, let's put this in the calculator. That would really probably help us out instead of me doing all this math. And turn on. There it is. I'm going to take the equation we just came up with, and I'm going to put this in the calculator. Y equals, let's clear this out. Let's go 19,378,000. Okay, yep. And I am going to multiply that times 1.015 raised to the x. And if I look at my table, okay, this should be the first value. Okay, after 1 year, I'm going to kind of blow these up here, these numbers. And then I'm going to do this. I will go, let's go 3 or 4 years. Let's go 4 years. This is year 4. This is the 4th number. See, when I highlight it, it gives me the number down here. Okay, so let's do the 3rd year. Okay, bring that out. 3 years after. I'm just going to layer these on top like this so it's easier to tell. 2nd year. second year, and this is the first year. We'll put this on top. Order, bring to front. There you go. These are the first 4 years. If I raise something by 1.5%, the population after year 1 should be this. After year 2 should be this. After year 3 should be this. After year 4 should be this number. Okay? So I'm going to try number 2 first and see if that works. Well, initially, the first element, that's this. Okay? It works out good. The first element, cha-ching. Okay? So let's take that and add 1.015 times the previous number. Okay? And we're going to have to keep on going, all right? So I'm going to take this out. I'm going to go back here, and let's see if this all comes out right. I'm going to take 19,378,000, and I'm going to multiply that times 1.015, okay, times the previous year. Okay, so if I want to find year 2, I multiply that times year 1. Oh, boy. Okay, which is 19,378,123. Boom, I hit enter. Okay, yeah, wow. That should be a plus, huh? I did times. Let's do this. Let's go back here. Hit a plus, hit enter. And that's, oh man, that's 3. Oh my God, that is, the second thing will be 39 million. That's not it at all. That is not it at all. So I'm going to go here. The second element would not be that at all, okay? Because I would want to only add 1.5% of the previous year. I don't want to include the whole previous year. That's why that boo-boo happens. This one right here is perfect. What does that mean? I start with this one right here. Good. And then I take 1.15 of the previous year, 1.015, okay? Let's do that and see if the numbers work out. Let's take 19,378,000 times 1.015. Okay, this should be my second one. 19,668,670. 19,668,670. Okay, good, that works. 19,668,670. Let's do it again. Let's multiply that times 1.015. 199,637. 199,637,00. Good, it works. And I can keep on going. Let's do it again. Times 1.015. Bam. 202,631,55. 202,631,55. Good. I think we got it. Yeah. A lot of algebraic stuff. Craziness. Anyways, you guys are good. Love ya. Let's get out of here.